Hello students, welcome to Spectra Educational Academy. In this video, I am going to explain a few more cases of connected bodies. This video is the continuation of the videos of video number 81 and 82, or otherwise you can refer the playlist explanation of the concept of formulas in Newton laws of motion in the playlist. Motion of two blocks in contact. Motion of two blocks in contact. Okay, just assume that this is a surface on which there are two blocks. Let us say this is block A of mass m1 and which is in contact with the another block of mass m2. So this is block B of mass m2. Suppose a force applied on block A. First we need to write the common acceleration. A is equal to F by m1 plus m2. Now let us clear the contact force. Block B moves only because of contact force, whereas the contact force opposes the block A. So therefore, for M2 or for block B, so contact force is the reason for its motion. It is M2A. So you can substitute the common acceleration. Therefore, it is F by M1 plus M2. Next, coming to for M1. So there is force directly acting on it, but it is opposed by contact force. So therefore, this is going to be M1A. So if there is a need to find out contact force only, you have to use this. Otherwise, if there is a need to find out the value of F, you have to follow this. So therefore, it looks like a formula. Then you can apply the same formula if numbers are given in place of M1, M2 or F, contact force or capital F. So this is going to be M1. So common acceleration is F by M1 plus M2. Yeah. Let us discuss the similar case. Suppose if force applied on block B. Once again, let us draw the diagram. Force applied on block B. So this is once again M1. This is block A of mass M1. So this is block B of mass M2. Now force applied on block B. So once again, the common acceleration is A is equal to F by M1 plus M2. Next up. So for M2, now let us list out the contact force. So therefore here M1 moves only because of contact force. But contact force opposes the motion of M2. Therefore, for M2, F minus F is equal to acceleration. So this is just like similar to force opposed. So therefore, it's application of parallelogram. So this is nothing but net force. So when there is net force exists, so there is acceleration produced. Next, so if question demands that to find out F or contact force small f, then A is equal to F by M1 plus M2. Next, so for M1, so M1 moves only because of contact force. F is equal to M1A. So therefore, M1 A is once again F by M1 plus M2. So this is when two bodies are in contact. So let us also discuss when three bodies are in contact, how the situation is. So for example, when three bodies are in contact, when three bodies are in contact. So once again, this is the horizontal surface. So this is body of mass m1. Call this is body A. This is of mass m2. This is body B. So and there is another body of mass m3. This is body C. Suppose if force applied on body A. So you can mention that if force applied on body or block, body A, then so first you write down common acceleration because together they move, F by m1 plus m2 plus m3. Then so let us list out how the contact force in between the blocks. So therefore, so here you call this is F2. M3 moves only because of F2, but F2 opposes the motion of M2. Whereas there is another contact here. So M2 moves only because of F1, but F1 opposes the motion of M1. So therefore, let us start from the last. For M3 moves only because of contact force. So F2 is equal to M2A. Then you can replace A with the F by M1 plus M2 plus M3. The next moving to for M2. So for M2, it moves because of F1, but it is opposed by F2. So motion of M2 is opposed by F2, but favors F1. So is equal to, this is M3A. It's also M3 because we are talking about the body M3. Now M2A. So therefore, this is going to be F by M1 plus M2 plus M3. Next, so coming to the part M1. So directly force applied acts, it favors the motion, but F1 opposes the motion of M1. So this is going to be M1A. So once again, you can replace A with F by M1 plus M2 plus M3. Next, suppose in this particular case, if a force applied, capital F is applied on M3. So let us discuss that. So this is once again horizontal surface. Once again horizontal surface. This is body of mass M1. Let us say this is A. Then this is going to be M2, B, and this is going to be M3. So C, now force applied on M3. So once again common acceleration remains same. F by M1 plus M2 plus M3. Then so let us list out how the contact force in between the blocks. So here F1 opposes the motion of M3, whereas F1 favors M2. So here F2 favors the motion of M1, F2 opposes the motion of M2. So now for M3, you start with M1 now. So M1 moves only because of F2. F2 is equal to M1A. So you can replace this acceleration once again with F by M1 plus M2 plus M3. Now, so for M2, so all the blocks are moving rightwards. So F1 favors M2, but F2 opposes M2 is equal to M2A. So M2 get multiplied with M1 plus M2 plus M3. Next, moving to for M3. So here capital F favors M3, but F1 opposes M3. So therefore, once again, so based on the question, you have to use any one of the formula to get the answer. So F by M1 plus M2 plus M3. Yeah, so these are the cases. Suppose the blocks are connected. If the blocks, this is another case, blocks are connected by a massless string. Massless string. So instead of contact force, you have to talk about tension. Tension is the reason for the motion of either block. Okay, let us discuss two bodies, two blocks connected. Two blocks connected. Yeah. Okay. So once again, you take two blocks. So this is a block 1 of mass M1. This is A, you call it as. So here you have B. Yeah, so this is M2. Now these two are connected by a string. So now force applied on M2. So now instead of contact force, you have to call it as tension. Tension is the stiffness or to hold the weight of the body in case of relief, in case when the lift is moving up or moving down. So now the tension, there is only one string, only one tension. So therefore tension opposes M2, but tension favors M1. So therefore common acceleration A is equal to F by M1 plus M2. So for M2, F favors but tension opposes. So it is going to be M2A, M2 of F by M1 plus M2. So this is for M2. So for M1, tension favors. Tension is equal to M1A, M1 F by M1 plus M2. In case, just to discuss the other case. Once again, you take two blocks. Suppose if force applied on block A. So this is M1, block A, this is M2, block B. Now these two are connected by a string. So force applied on A. So therefore, once again, common acceleration is F by M1 plus M2. So coming to the part, individual. So here, tension favors M2, but tension opposes M1. So therefore, for M1, force favors, but tension opposes. So therefore, M1A, M1 of F by M1 plus M2. Next term. For M2, so tension only is the reason for for its motion. M2A, M2 of F by M1 plus M2. Suppose when three bodies are connected. When three bodies are connected. So three bodies are connected means what? At least two strings we require. So once again, this is the horizontal surface. So this is block A of mass M1. And this is block B of mass M2. And this is block C of mass M3. So now this is connected with the first string, connected with the second string. And let us say force applied on block C. So now how tension favors and tension opposes. So here first, let us say this is second string. So tension T2 opposes block C, but tension T2 favors M2. Similarly, tension T1 opposes M2, tension T1 favors M1. So now once again common acceleration F by M1 plus M2 plus M3. Okay, so now individually for M3, last one is M3, force favors, but the T2 opposes. Of course, friction cases also will be there. That will be taken up later. F minus T2 is equal to M3A, M3 of F by M1 plus M2 plus M3. Next. So this is once again F minus C2. So for M2, T2 favors, but a T1 opposes. So this is going to be M2A, M2 of M1 plus M2 plus. So you can frame even multi-option questions also based on this. This is for M2. Now last M1. For M1, so T1 is only the reason. M1A, M1 of F by M1 plus M2 plus M3. Right. So let us discuss the reverse case here. The force applied on block A. So based on the question, you have to respond. So once again, this is the horizontal surface. So this is block A of mass M1. So this is block B of mass M2. This is block C of mass M3. Now, so this is connected with the string. Let us say first string and second string here. Now force applied on block A. So let us see how the tension opposes and favors. So here T1 opposes M1 but F favors. But T1 favors M2. So T2 opposes M2. T2 favors M3 because all the blocks are moving from right to left. So first common acceleration F by M1 plus M2 plus M3. Next, so individually, let us start with M1 for M1. So F favors. So this is once again the application of parallelogram only. So theta angle between force and tension are 180. So just to get back, C is equal to A minus B. In parallelogram, we have A square plus B square plus 2AB cos theta. So theta is 180. You will finally get, after you simplify, C is equal to A minus B only. C is the net force, you call it as. So now T1 opposes the motion of M1. And when applied force is greater, it poses acceleration and there is existence of net force. So therefore, M1 F by M1 plus M2 plus M3. So this is the first case for M2. So T1 favors, but T2 opposes. So is equal to M2A. Then next. So you can replace once again A, F by, because together they are moving, M2 plus M3. Next. So T1 minus T2. After that, for M1, so F favors, but it is opposed by tension instead of contact force. Tension T1 is equal to M1A. M1 with acceleration is once again M1 plus M2 plus M3. Okay. So students, in my next video, I'll continue with the motion of the blocks when the string connected passes over the pulleys. Thank you very much for watching my video, but don't forget to share and subscribe with your friends and relatives.